going live now, actually. So we are live now. Hello, everybody. We are live. Welcome to this new webinar by Aerodynamics. We've got Javi here with me, and I've got Pedro as well with me. Hello, everyone. Please let us know where you are joining us from, what your names are, and what are you really looking forward to learning today. I've got Javi and Pedro, so please say hi.
Hello, guys.
Hello, everyone. Welcome, everybody.
And we will be starting in just a few minutes while we let everyone join us.
Se ha perdido la imagen, estamos como en espera, ¿sabes?
Okay. Right, we're just going to give the last few minutes for everyone to join us, and we are ready to go. I can see hi from Portugal. We've got Patricia from India. We've got Esteban from Spain. We've got Carlota from Spain. We've got Lucia from Milan. We've got Cassie from Poland. We've got Claire from Switzerland. Someone from Sao Paulo, Brazil as well. From UK. Right, we good to make a start, Javi?
Yeah, let's do it.
Cool. Well, with us today we've got Javi and Pedro, and today it's a very special one because it's the very first one we're doing with Pedro, which is the new Racetrack Dynamics acquisition to the team. So you will get to know everything about him. In the meantime, do let us know if you've got any issues with the audio or the video, everything. We're not quite pro streamers yet, so we're still working on everything. But just before we kick it off, we've got a brief disclaimer to start with, which is that we're not professionals. We're not professionals in any working in any of the F1 teams that we were working with previously, so that all of the conclusions and all of the information that we've got in this webinar are our own experiences, our own studies. None of the information is taken from any previous F1 team. We are not associated or affiliated with any of them, and all the information here is from the public domain or generated by ourselves. Moving on, we're going to make a start with Racetrack Dynamics, which you already know of, as you're clearly already here. It was this project created by Javi and me a few years back when we met, both working at Red Bull Racing. Since then, Javi moved over to Sauber, now Audi, to be Nico Hülkenberg's performance engineer, and that's when I moved to do full-time Racetrack Dynamics. But then we got Pedro join the team. So Pedro is an ex-Red Bull Racing aerodynamicist. He was working as part of the Adrian Newey's team. He was designing the floor for... Well, I'll let Pedro explain yourself, actually. What were you doing at Red Bull, Pedro? Go and tell us.
Hi, guys. Yeah, I was in Red Bull from 2021 to 2023. I still got to the later stages of the really nice 2021 title battle between Max and Lewis. It was some hectic times. When I joined, we were already developing the new generation cars. So I've worked in the floor of the RB18, RB19, and a bit of RB20. And yeah, it was really nice, really fast-paced. And I hope I can transmit some of the knowledge to you guys today.
Amazing. Well, moving on, we've got quite a busy day for today. So we're just going to go right into the depth of it. So 2025 versus 2026, we've got significantly smaller and lighter cars. As you can see, all the cars just become a little bit smaller, a little bit more raceable, a little bit lighter. You can see here in the stats, about 100 millimeters smaller, about 200 millimeters sort of slimmer in terms of wheelbase, a little nice reduction in weight, and although the tyres are still the same, we still get a slight reduction in the overall diameter, as well as less overall downforce, which Pedro will go into in a minute. And we've got two very exciting aero modes, which Pedro will also talk about in a minute. Moving on, we've got the changes to the power unit, which is what I was working on when I was at Red Bull. I was at the powertrains department. I was actually designing the turbocharger, meaning this is kind of my area. And what basically changed is we're going from the electric power of the engine is becoming way more important. So we're going to have way more electric power. We're having way more electric power, which that can have both good and bad things, as we will see. And one of the power unit implications is the fact that we no longer have an MGU-H. So the MGU-H, which is effectively like a fancy smart turbo, it used a lot of expensive components. The power electronics were really expensive. It was hard to manufacture. It was hard to come by, and that is why it's one of the reasons why they're getting rid of it. So now it becoming a standard turbocharger, which we will see in a minute. Everything else is effectively a similar kind of thing. We've still got an internal combustion engine, which burns the fuel into mechanical energy. We've still got the MGU-K, which can, it can recover energy during braking, and a lot of the different energy recovery modes, which we will go to in a minute. And we've still got the energy store, which is our battery pack, which is becoming effectively way more predominant in the performance of these generations cars. Moving on, we've got effectively, just diving a little bit deeper into the turbochargers. We've got that they are effectively the same thing. It's just that they are no longer smart. They are no longer activated. You can no longer use them to deploy energy or recover energy into the battery system, meaning that it will effectively do its own thing, which means we've got turbo lag back, which will affect the driving style. For any of you not familiar with it, turbo lag is when the turbo takes some time to spin up, so there will be some delay between when the power is down on the throttle on the engine and when you actually have the turbo spinning up and creating the boost pressure to provide the extra power that we require. As such, this year we've seen just before the lights go out, we've seen some of the drivers having higher RPM starts to try and boost those turbo RPMs to get more boost at the time that the lights go out. It's generally a lot cheaper and a lot simpler to build and manufacture than previously. But effectively, it's still a turbo. It still works in a very similar way. Over to you, Javi.
Thank you, Alex. So first off, I've seen already some questions in the chat asking about the certificates, whether people will be getting those at the end or not. Alex, I don't know if you want to answer that.
Absolutely, yes. At the very end, we will have a link where you can go into both with a QR code and with a link, and you can request your certificate of participation, and we will have it delivered to your inbox within 24 hours, so you can put it on your LinkedIn and you can show everyone all the new things that you've learned today.
All right, so back to the technical part. So this year we've seen a reduction in the capacity, in the power of the ICE, so it's taking around 25% of the power that we had in 2025. So that, coupled with an increase in the electrical or MGU-K side of things, is now splitting the power, as some of you guys were already discussing on the chat, to a ratio of around 50 to 50, mechanical to, let's say, ICE to electrical ratio. Of course, to satisfy this much powerful electrical engine, this new K, the harvesting energy that is allowed per lap has bumped up from 2 to 9 megajoules, which is a lot higher than last year. And this puts, again, emphasis on how important it is to nail and to get your energy deployment and harvesting strategy right in the lab, because there is a big lab time sensitivity to it. So big changes, 25 to 2026, we had the previous DRS or drag reduction system, which was enabling cars to have a higher terminal speed and facilitating overtakes in some designated straights. Now what we have is an overtake. We have an overtake mode, which is enabling us to do these overtakes, which of course is also consuming some of the energy that we have in the battery. Now, on the other hand, this overtake can be used anywhere. So it's up to you where you use this energy and how. So it's much more dynamic, much more strategic, because also it has downsides. So before, you could just open your DRS and then you will gain that terminal velocity that will put you in advantage to the car ahead that you were chasing. But now it will come also with some drawback on the energy that you will be missing for the next straight or for the next corner. So that's a bit of a change in the scene at the moment. We got now, to facilitate these 3 buttons, we got the boost button, recharge, and overtake. Essentially, boost button gives maximum power at the FIA limit. So we will see it. We'll cover that in a minute. It could be used anywhere. Then there is the recharge button, which forces the car to go into harvesting mode, to go into a more less deployment of energy, more recharging, more trying to build this positive shock delta to try to get this energy back to use it later in a more strategic place across the lap. And of course, the overtake mode, which is similar as the boost button, forcing the engine to go to the maximum capacity, the maximum power, the electrical engine, but it gives another extra boost that is another limit. We'll see that in a bit. I hope it's a little bit more clear, the boost versus overtake, the different electric regimes. So going back, sorry, Pedro, going back to also to the overtake mode, there is another thing that is helping us to do these overtakes, which obviously the cars are now very sensitive to energy. To every megajoule we are able to recover in the lap. It gives us a large amount of lap time, of course. So when we're 1 second ahead of the car ahead and we have this overtake mode, it does not only enable us to go a little bit farther in the power that we deploy in our electrical engine, but also gives us the ability to recover an extra 0.5 megajoule across the lap. So that puts us in a double advantage when chasing a competitor ahead. Now you can go ahead. One thing that the FIA has limited and has been trying to limit is this limit. They have been trying to limit the harvesting that you can do in a lap, even in a quali lap. The reason behind was trying to still maintain cars that still kind of perform and look like race cars. So you could still see the kind of race car shape in the telemetry, in the velocity, and they do no longer derate massively or super clip as we see now in some of the races. I mean, of course, seeing that in the race is one thing, but seeing that in qualifying when the car must be at the absolute limit, it's another. So it's even much more sad. So that's what what they are trying to limit. They're trying to limit precisely this shape, this parabolic shape that we see here, where we see here in the sector 2 of Russell. So trying to prevent this a little bit, but essentially it's still happening. The reason why is because it becomes very. If we do a basic experiment, if we play with if we play with a simple model and we do some simulations and some experiments, it becomes very, very clear that the most efficient place to use the energy is always the start of the straight, and the place where it's less efficient to use your energy is the end of the straight. So one will always be wanting to recover as much energy at the end of the straight to use it at the exit of the corner. So you can benefit of this delta that you build in terms of velocity and also right across the straight. One other thing to be mindful is the deployment reduction rate, which is going to be defining the regulations as well. So you can no longer you cannot go from 350 kilowatts of deployment to 0 kilowatts of deployment. You need to go through this staircase shape and go in at these 100 or 50, depending on the truck, kilowatts per second steps. So this is going to change from one truck to another. Here we can see what the C5 2.8 regulations are dictating in terms of the maximum power that our electrical engine can deliver across the lap. We see 2 revs. The base is the standard that is going to be used in most of the trucks. I believe blue or rev 1 is going to be used in some trucks like Monaco, where the power is going to be limited. So now we see that we've been talking a lot about this maximum electrical power that has been 350. Everybody knows that, but it's not so well known that the power actually goes down and is limited when you go past 290 kph to yeah. So when you're trying to, if you were to use your boost button to use all the maximum power and all your energy from your battery, the maximum power you could be using in your car will be following the solid line in pink. But when you are trying to overtake, then this mode enables where you could then be sitting on the dash line, of course. So all this shape between all this area between the dash and the solid is the pace delta that you will build with your respect to your car ahead, just by using the overtake button. So in 2025, yeah, that was flat. So we were saying that the best place to deploy energy is the beginning of the acceleration events. So this enables a lot of strategies, a lot of scenarios. So that's why also it's very critical. It's critical to pay attention to what the cars ahead are showing. They are giving us with their flashing lights. So the codes are 1 flash, meaning that the MGU-K is delivering less than the maximum power, less than 350. So it's not under maximum deployment. 2 flashes are telling us that the MGU-K is not delivering power, so it's not less than 350 at that moment. And multiple quick flashes are telling us that the MGU-K is not only not deploying energy, but it's being loaded against the ICE to recover even more energy, so kind of super clipping. And that's going to be even more dangerous because the speed is going to decrease. Of course, the car has negative electrical power, and yeah, we might see some incidents like we saw on Suzuka with Berman. Yeah, precisely. So some of the new power unit modes that we will be seeing in 2026 are that were not present in 2025 are the part load acceleration. When driver is not requesting the full power of the ICE, what the control unit is going to say, okay, my engine only needs to deliver 100 kilowatts, but it could be delivering 400 kilowatts more. What I'm going to do is fire up my ICE to the maximum. I'm going to use my combustion engine to the maximum, and all the excess of energy that I'm not using, all these 400 kilowatts that I'm not using, I'm going to use them to burn fuel and to charge my batteries against that. So all these zero net emissions and green philosophy is just a dream because essentially we're still burning fuel just to charge our batteries. We have the super famous super clip. This 2026 is taking all the headlines, right? So essentially when the MGU-K is not only not delivering power to save energy, but also is acting against and trying to recover even more. So we see this dramatic loss of velocity and the end of the straights. We see the regenerative lift off, which is when the driver lifts off the throttle, then the K kind of engages and tries to recover energy as well. And then the power load overload braking, which is a quite interesting mode as well, in which if the brakes have capacity to brake more, so when there will be an increase in the ICE torque, even when the driver is braking, because the brakes have so much capacity to brake more. So it's you're actually even accelerating when braking. It's a little bit strange, this one. So it's true that there is a limit by the FIA of the limit of the maximum power that you can use and on the maximum amount of energy that you can recover through a lap. But there is another variable, which is the efficiency, which is going to separate a lot winners from losers. Good engine good battery manufacturers and bad battery manufacturers. So imagine that 9 megajoules are available for regeneration for every lap. And we consider two scenarios. We consider 95% efficiency and a 90% efficiency. So for a 9 megajoules of available energy, that equals 855 megajoules and 8.10 megajoules in the battery. So that is a 0.45 megajoules delta. This 0.5 megajoules delta that we really put into the batteries, because our system is more efficient, if we consider a generic kind of average through the season, maybe a little bit higher, but 0.5 seconds per megajoules of lap time sensitivity to energy, that equals roughly 0.2 per lap, which is a lot. So over 50 race lap distance, that's like 10 seconds of deficit that you have there. So I think it's pretty clear at this point that the emphasis has moved from the driver to the engine and to the strategy. And yes, the drivers are just passengers at this point, no? And I will pass it to Pedro to comment briefly on what has changed in terms of aero.
Thank you. Hello, guys. Thanks for joining again. So first, I'd like to start with this sentence here, that to defend all the hard aero work that goes on behind the scenes, that downforce still matters, right? So we're talking a lot about battery and regeneration. And I hear some comments saying that this formula rewards some, let's say, slower cornering, right? So the idea is that we brake more before a corner, so we actually regenerate, harvest more energy, and then we can deploy that on corner exit, and we'll be better off, even if we are slow through the corner, which means that the corner is not grip limited. From the first 3 races in the season, we see that these happen sometimes, especially in some particular set of conditions, that when you have a corner that you don't spend a lot of time, and then you have a big straight ahead. So if you look at any type of corner in the calendar, you can ask yourself a couple of questions like, is the driver spending a lot of time in that corner? And do I have no straight or a very short straight afterwards? And if the answer to both of those questions is yes, then you likely still have a grip limited corner. And in that case, you want all the downforce in the world, preferably created in a very efficient way. This to say that everyone will be working very hard, wind tunnel, CFD, track testing, to bring as much downforce as possible. You already saw some teams talking about the big Miami upgrade package that they will bring. Because, for example, imagine China turn 1. Drivers are in the straight, they brake really early. You saw the onboards. But then you have that really long sweeping corner. And the more downforce you have, the faster you go through that corner. It's simply as that. And besides the sheer speed that you can achieve by more downforce, there's also other obvious benefits. So if you can generate more load in the front and the rear, you have more budget to basically remove or add downforce where you want, which means you can shift your aero balance the way that track demands. You can make the car more predictable, more driver-friendly, and a confident driver is a fast driver, as long as it doesn't put it in the wall. And obviously, you'll have less sliding mid-corner, so that will also mean that the tires will degrade less over a race distance. This being said, that downforce is still king or queen. As Javi and Alex said, that DRS is not present anymore. So before you had, let's say, an active mechanism of overtaking by opening the rear wing flap. Right now, the straight mode or the X mode is used mainly to allow the ICE power expenditure to be charging the battery instead of helping in your overtake. The X mode has a positive effect of inducing a different aero balance shift. So last year, you are in a straight, you open your rear wing, and then your aero balance, which for the people that are less accustomed to these names, it basically is the relation between your rear axle and front axle downforce. You can imagine if you open only your rear flap, all your downforce or more downforce of the car is concentrated in the front. So if you want to go through a corner and your front tires are really, really grippy, but your rear ones are, let's say, not as grippy, the driver cannot take the corner with the DRS open because the rear just snaps out and you basically crash. The X mode does the nice thing of both the front and rear flaps of the front and rear wing open. So you lose downforce in a more consistent way or predictable way. So you know you can take a corner slower, but at least your car is not going to make weird things. The rear is not going to go crazy when you turn in the car. And you can see in Australia, for example, they were able to go through that long mid-twisty section with the X mode deployed. So a lot has changed. Sorry, this is not working. It's working now. A lot has changed. Obviously, in a open wheel formula, such as Formula One, you have these four little things here that are quite annoying. They rotate really fast, and they are rotating at 300 kph against the wind. So you can imagine when you are in your car and put your hand outside your window, you already feel a lot of vibrations. The wheels of these Formula One cars generate massive amounts of turbulent, dirty air. It's what teams usually call the wake of the tire. And if I draw, usually what the teams try to do is a lot of the front wing is, okay, I have a lot of turbulence here, so I just want to put it out and maybe up. And this means that this dirty air is going to be put away from my car. The problem is, obviously, it comes back, right? So if I put it out, then it will come back down here. And then I can have other car here, and all my dirty air will go into the front wing of the other car, and that basically reduces the ability of the cars to follow each other. So the FIA, basically for these regs, said, we want to limit the ability of the teams to create this outwash. What we will do is we'll force the F1 teams to make their floors and rear wings work in a more dirty environment. So all these tire wake that before it was trying to put outboard, the FIA wants it to go instead inboard here. And they've achieved this with a couple of things. First, you can see here your front wing, your end plates. Usually we generate a vortex that does something like this, and you basically flush or outwash your wake outward. Right now, you can see that they've put these end plate really inboard, which means that our structure now, this vortex that it generates, will probably be going somewhere here. So we have limited amount of authority on what happens to this front wheel wake here. And from a bit downstream of the front wing, you see these little, or these, not little, these big floorboards. If you see them from the top, you can also see that they go like this, inboard. These will bring the wake further in and limit the abilities that the teams have to push this front wheel dirty air out. It will be ingested by a bit of the side pods, here the openings, and goes on top of the floor surface here into the rear corner, a bit into the diffuser, and probably some of it gets ingested here on the front floor. The floors are now way less complex, than last year. They are flat, it's mandatory. The cars have also become, we would argue, a bit less ride height sensitive. So that allows for a broader setup window. We'll talk a bit more of that later. And this has the good thing of less compromise with the mechanical setup. So then the guys in Javi's department are very happy because they can really choose the best suspension for every circuit layout, and the driver can just eat the curbs like there's nothing. Going a bit into the detail in the different parts of the car. So front wing, as I said, the end plates are more inboard here. probably when you have a lot of crosswind, so the wind coming from the side, the structure of the end plates perhaps still can end up outside or outboard of these tires, but I wouldn't 100% commit to this statement. This is a speculation. Since it's early stages of the new regs, you see that there's a lot of variance in how the teams choose where to place their load in the front wing. So for example, here McLaren, you see a very cranked outboard loads concept, while for example, Mercedes has a much more evenly distributed load span-wise. Some teams have these horizontal, slightly downwashing winglets that protrudes from the end plate. And this likely creates a little structure here for wake control, and you probably also interact a bit with your tire squish. Squish is what we call basically the air that gets eaten by the tire or crushed into the ground or the track by the tire. We call that the squish. And you see that there's a lot of variance in these front wing mountings, like these koi carp, I call it antennas. So for example, Merck has decided to attach the nose pylon to the second element, McLaren to the main, so the first element, and they're varying quite a bit in length. So a lot of different concepts here. And you also see the return of these nice little foot plates, which increase effectively a bit the span of the wing and house a nice little vortex here on the underside. Of the floor lost a lot of complexity. You can see here on the bottom, the 2020 regulation cycle, you have a flat underfloor. 2022 to 5, you had these strakes that generated a complex vortex system that went into your floor. The interaction with this in the ride height maps, the rest of the main tunnel was quite complex. For 26, they're a bit simpler again. So flat, these strakes have gone. We now have these smaller strakes that produce smaller structures, so they don't last as much downstream as the previous ones. The total area of the floor is also smaller, which means less overall downforce, which is slightly compensated by the reduction in weight of the cars. You also have these in-washing floorboards that I mentioned from plan view. There are quite some different concepts we'll show afterwards in these floorboards. These basically, the teams are allowed up to 3 sections. They can be made of vertical, diagonal, horizontal elements. That's quite some freedom to conjugate these design ideas. And the teams will basically choose what they do with the floorboards together with their front wheel concept. So how am I managing my front wheel wake? The interaction I have with my sidepod inlets and sidepod shape, and also how wide is here my floor, so the top of my floor here, and also what do I want to do with this piece of floor here? So how am I generating this vortex on the edge of the floor? Regarding the floor edge, perhaps some of you remember that last year there was some funky wings going on here. A lot of aerodynamic devices. So they're gone. The edge looks a lot simpler, but we still see these, we call it the extraction region here. So if you imagine the air goes into the floor here, right? You obviously generate some structures around here in these strakes, but then the air keeps going like this on the underside. If you just induce a curvature around here, you effectively put the low pressure here, which means that you're extracting your air from underside the car, and it will be all nicely up and outwashed from the floor, which provides you with some local load here in the front. And then also you start the roll-up of an edge vortex a bit later on. And you see, for example, the communication between the different elements is still relevant in these regs. So you have a nice little curvature here, which means that you have low pressure locally. These will communicate nicely with the extraction we're having here. And also the side pods, low pressure, will also help this extraction. is a bit of aero analysis, but to say that the mechanisms of the car, some of them were transported, and it's still very relevant to look at the aerodynamics as a system, not just as a local part, right? You see here the different designs that teams went to. Majority of them went to these flat horizontal structures. For example, Ferrari has a vertical vane. Alpine has some mixture, or let's say a combo of surfaces and edges, probably shedding some counter-rotating vortices here that will be useful later on. But there's a lot of, let's say, freedom across the grid, and people come up with these different designs, which I think it's really nice, and also to speculate about who's doing what. The diffuser. So we have the comeback of these really nice and funky aero, aero devices. So we can flap the floor, for example. We can introduce some cutouts. And basically, these structures will have a lot of benefits, both for controlling what happens upstream in the floor, and also to control what happens in the wake and the squish of the rear tire. The diffuser concept also changed. So in the previous regs, the floor worked the air so hard that the diffuser was, let's say, not the main downforce generating part on its own. It obviously helped the floor to work, but the air didn't have a lot of CPT. CPT, for the people that are a bit less experienced, we can define it as a measure of how much work can the air still perform. So it goes from 0 to 1. 1 is beautiful, clean air, and 0, it's completely turbulent, used, separated, whatever, air that you cannot generate downforce with. So you have these nice little vanes. They will produce some local vortices, probably prevent some cross-flow locally. And you have this also nice cutout on the diffuser. So these will not only allow for any structure that you form here. So let's say, imagine I have a vortex here that's producing downforce or low pressure locally. It can nicely flow into my diffuser and then still act upon the surface of the diffuser. But you also inject a bit of CPT. So you have air coming from the outside that is not as used as the one that came from the front of the floor. And these will allow most likely a more constant or predictable behavior of the diffuser across rear radiates. So that means that you have probably a flatter rear radiate versus rear downforce curve. And that's what allows you to have a broader setup window, as I mentioned before. I'm happy to delve into this a bit more. If there are questions in the chat, Javi, let me know. Otherwise, I'll proceed. I can go back if the answer is yes. You see here that when the air comes in this little cutout, I'll just explain it. We have time, right? Yeah, so the air comes in, and you can imagine last year, the lower you go, the faster the car is, the faster the air flows underneath the car, low CP, sorry. There was a point that if you load the car too much, you suddenly go into losses, right? You work your air too much. And the teams had quite some trouble predicting that in the wind tunnel or CFD, because that meant you have to predict very, very well what happens all the way to the front of the floor. So there was some miscorrelation here. You can imagine that if you introduce some air here that is not, let's say, worked, so with higher CP, you introduce a pressurization that will affect the behavior of all the floor. And that will affect your high-speed case a lot, but it will also mean that you don't have those low rear radiate losses as you had before. So that allows you for a much more predictable behavior. And you have this nice little curvature right downstream of the opening. It's basically you're saying, okay, let's create a low pressure so that the air that comes in does not pressurize as much the front part of it and just starts to flow into our diffuser. A bit less technical now. Sorry for that. You have a new engine formula, so teams are still figuring out their different cooling philosophies. You see that you have some tighter packaging like Merck, Red Bull has a bit more of a big opening here. The goal is still the same, right? We want enough cooling while reducing the drag and optimizing the interaction with our rear wing, rear suspension and diffuser. Your side pods are still downwashing into your rear corner as before. And as I mentioned before, you still have your suction peak here on the side pods and junction with the chassis, helping your extraction here from underneath the car. Rear wing, you still have a 3-element rear wing. Sorry, you had the 2-element rear wing last year. Load is quite concentrated on the main plane, and the 2 upper flaps will be actuated in the X mode. You see Merck still finding some cheeky little 4th element, so some loopholes are still being found, which is really nice to see. And we actually got some different approaches to the straight line mode we were seeing. So majority of on the grid, they went for a system where the upper 2 flaps, which need to maintain their, let's say, relative position when the mode is deployed, the actuator is on the top. So you open a gap between the main element and the 2 flaps. Other teams, such as Alpine, they went for a different solution. So their actuator is positioned in such a way that it's the top that goes down, like in this drawing here. And then you have Ferrari that did this really nice thing. We'll go a bit more into depth later. And basically, look at this low CP here. This will correspond to your normal straight line mode deployment. That would be how low your CP would go here. The idea is that once you rotate the whole wing, the place where you end up here is, you cannot see it, but lower than the previous ones, which means that in theory, your induced drag is a bit reduced. We'll analyze it a bit further. And then you also have the different positions explained in a video. Come on. Yeah. So again, you see that majority of teams went as with the Red Bull solution. Audi, well done, Javi, did from the center, and Alpine went from the bottom. Right. Regarding the Ferrari approach, Javi, we're still on time? You muted, but I'll think yes.
Yeah, Javi was muted. Yeah, don't take too long, but you can still go out.
All right. So very quickly, the Ferrari approach in Bahrain of this rotating wing, we surprised us all. It's a lot of innovation because it rotates to 180 degrees. One thing immediately jumps out is that it takes a bit more time to activate. It's limited to 0.4 of a second, but if the DRS activates in 0.1, then you can still be a bit short or have a shorter distance of open flap. So that might penalize you. Another thing that occurs is if you look at this video from Lewis defending from George in Japan, this is the normal DRS, and Lewis is moving a bit under braking. DRS closes as soon as he touches the brake, and this is fine. I'll put it from the beginning. Now imagine that you have your fully rotated wing. You are a bit defending. You will start to induce, or you are turning into a corner without braking, and then you do a bit of trail braking, meaning you're inducing a moment in your car. If you do have a wing that is doing funky stuff and your CP is varying a lot on the rear, I'm afraid that will create a lot of instabilities under braking, and I'm not sure the drivers will like that in some of the corners in the calendar where you do need to brake and turn at the same time.
This is a very, very good point, Pedro.
Yeah. I prepared this bit of air analysis on the Ferrari simulation, on the Ferrari straight line mode. I will try to go over that quickly. So first compare the Z mode or cornering mode with the X or straight mode. Immediately you see, and for the sake of explanation for the least accustomed to this, red is high pressure, blue is low pressure. What generating downforce, we want this differential between up and low surface to be maximized. So in X mode, you see that we open the flaps, meaning that we are putting some suction here, so low pressure, next to the top of the main wing. So this will reduce the high pressure we have here. At the same time, the low side, where we had low pressure, is not communicating well with the flaps anymore. So you see that we lose both low pressure on the bottom and we lose high pressure on the top. So that makes us lose downforce. That's how the DRS works. The less downforce means less induced drag, so we'll have a less draggy wing. In X mode of Ferrari, you see that the difference in colors between up and low surface is even more. This is because now the flaps are completely rotated, so the suction side is not communicating with the main wing at all. It's quite tricky how they will cope with having the leading edge becoming trailing edge and vice versa. But this loss of overall load in the main plane means that you have less induced drag, and you also have some higher pressure communicating with the diffuser, which perhaps decreases the overall downforce your car produces. And this is very useful if you think about what happened to McLaren last year. They were disqualified by plank wear, because at the end of the straight, you are producing so much downforce that your car is being pushed to the ground and you wear down your plank. So if at the end of the straight, you are not producing as much downforce with your DRS or X mode open, you basically can set your car a bit lower, which means that at the other parts of the track, you can benefit from the car being lower and basically be faster than your competitors, because you know that you will not wear the plank so much in the end of the straight. And the final slide for me is this really nice comparison. You can see there's the pylon differences between the teams, the flap geometry, where they're mounted. And I think it's really nice in the beginning of a regulation that we can appreciate like the hard work that all the engineers put in. They come up with these very different solutions, and in the end, the cars differ now, let's say a second because of the engine, but it all converges eventually, let's say in 1-2 years. But for now, it's really nice to see the amount of different designs people come up with. And yeah, we should praise this creativity because it's really, really nice work to see. Back to you, Javi. I think you're muted, mate.
Thank you very much.
Thank you, Pedro. Very good job on these explanations. It was clear even for me, so learn a couple of things about aero. So now I'm going to take you everybody for a quick lap around Bahrain. We're going to see how 2025 to 2026 has changed it, because everybody likes telemetry. So the first thing we can see is that we have a much more efficient aero package. We have less drag. We have higher terminal speeds relative to 2025. We start to see this parabolic kind of shape, which doesn't look anymore like Formula One, induced by this super clipping and lift off at the end of the straight into T1. We see overall less downforce, which is evidenced by smaller minimum speeds, which we can see in 1. In 1, 5, where 6, 7, it's a mess. We can see it in 11 a lot, 12, everywhere essentially. So we see also a big reduction in velocity in the high-speed section in Bahrain, which is no longer a high-speed section, and the left, yeah, there it is. And it looks more like medium speed now. It's not high speed anymore. And yeah, so if we add this reduction in downforce, which now is around 50%, or in the order of less to 2025, coupled with that, there is now no incentive to push and deploy energy in high speed because it's going to be less efficient. It's going to damage your tires. So there is, again, this we see this big delta. We see even in the braking areas, we see the decrease of downforce, which reduces the braking performance. We see it after the high-speed section, as you can see there. And yeah, just everywhere, minimum speeds in 11, a big difference. Again, just very different cars. And yeah, so essentially we have cars that now should be more raceable, but there are less engineering machines, less aerodynamic capable, and just less exciting, in my opinion. And that's it. I'll pass it to you again, Alex.
Thank you very much, Javi, and thank you very much everyone who stayed this long with us. Now we've got quite a few exciting announcements on 3 different fields of Formula One engineering. So we're going to start off with aerodynamics, and is that we're announcing a course with Pedro. So the complete guide to aerodynamics in F1 is now available. You just saw a little sneak peek of what Pedro is capable of. Imagine what he's like over 12 hours over a weekend, explaining you everything he's learned over the many years he's been doing aerodynamics for. It's going to be happening on the 16th and 17th of May, presented by Pedro. It's going to be available for all of you to join, and all you need is a high school background in maths, physics, and or some type of engineering. It's available for €649, and we do have scholarships available, which we will go into in a minute. Again, this is a great opportunity for any of you wanting to go into Formula One engineering, especially to aerodynamics. This is your chance to learn from our local ex-Red Bull Racing pro.
If I may, I can do a couple of words. So I've tried to put the course basically announcing or putting together a couple of things very, very broad, let's say, in various areas, things that I wish I knew when I joined the team. And it goes through a lot of the different aspects that involve producing a car, from the wind tunnel, the aero dev, aero analysis, relationship with vehicle dynamics, the way the team works, some cool stories. So yeah, I've put it the way I wanted to have had access to when I joined the team.
Thank you very much, Pedro. This is exactly what we aim for. We aim to be an alternative for getting people into motorsport. We all know the 30 grand a year motorsport masters and everything, but this is exactly because that's not accessible for everyone. That's why we made the F1 engineering scholarship, which can get you up to 100% off in this aero adventure of yours, and you can get the complete guide to aerodynamics in F1, exclusive access to our F1 CV building workshop, the F1 aero handbook, and effectively direct F1 engineering mentorship from us 3 to help you in your path into Formula One. And yes, this can be you just have to apply for this. This can be free for you. What does it take? Next up, all you need to be able to apply to this scholarship is to be a current student or a recent graduate of some sort of engineering, physics, or mathematics degree from anywhere in the world, literally anywhere in the world. You need to be able to demonstrate your technical interest in motorsport engineering via projects, via the things that you do in your free time, your hobbies, the books that you read. Anything really works. You just need to see how technically interested you are and that you're really proactive and that you will make the most out of this program. We want to engage students. We want students that will make the most out of this program. As this is actually a fantastic opportunity to have people go into Formula One. Over the past year, we've had a few successful of our vehicle dynamics course attendees get actually hired by Formula One teams. We've got students at Aston Martin Racing, we've got students at Mercedes HPP, and as such, we're looking forward to continuing this into the aerodynamics side of things. Moving on. Is this really free? Can you really get this for free? The answer is yes. You can absolutely get this for free. We're going to be running a blended model, which has several different tiers. So you can get it from free to heavily discounted, depending on availability, how many applications we get, and what your particular background is. This is what allows us to make this education accessible and sustainable over the long term. We would love to be able to run these courses completely free and have 200 people in there for free. But because we need to make this sustainable and we need to pay Pedro, we need to pay the other employees. Pedro needs to eat. we're running this blended model where some of you will be able to go in for free, and we're having the heavily discounted tiers, and we're mixing it in with professionals and people that are not eligible for the scholarship that are also going to be joining this course. Scholarships will be awarded on a first come first served basis, and as we said, the available spots are very limited, so you can 100% get this for completely free. Just be sure to apply, put all of your energy, put all of your engineering thoughts into making it as clever as possible, and apply as soon as possible, because the spots are very limited and come on a first come first served basis. You can apply on our website, racetrack.dynamics.com/scholarships. You can just go in and have a look. It's a very simple application. We'll just ask for your motivation, a bit of your background, some admin stuff, and we just want a 1-minute video as well from you, seeing what you like, what your motivation is, and why you really want to be part of this scholarship. Moving on, we've got some incentives for you guys that are here in the webinar. So you guys, by being in this webinar, you're already ahead of everyone else. You're already putting in the extra effort, the extra mile to become that F1 engineer that you want to be. So as such, we're launching a 40% discount for the first 5 registrations for all professionals and people that do not want to apply to the scholarship. You can apply as a student. You can buy it as a student, of course, if you don't want to go through the scholarship, or if you want to guarantee yourself a spot. Code is webinar40. That is the largest discount we have ever done. If anyone in the chat has been following us for years, you will know that we have never made a discount this big. So this is really like the biggest we've ever done. So this is your chance to get it. The code will become active as soon as this webinar finishes, to give everyone an equal chance to join. And for students applying, thank you for being here. Thank you for staying with us. We're going to give you priority at the time of the application, meaning that we will check your applications first, and because it's a first come first served basis, you will have higher chances of being accepted into it. There will be a field called do you have a code, and for that you can enter Webby priority, and we will assess all of those applications first. Moving on, and to some other non-aero things, a complete guide to vehicle dynamics, 20th and 21st of June, ran by Legend Javi, is happening in June. Price €299. This one is available for everyone. We don't have a scholarship for this at the minute. And again, anyone with high school background in maths and physics or engineering is able to join. Anything you want to say about this one, Javi?
I will try to make it as exciting as always. That's all I can say.
Amazing. This is the fifth time that we're running this course. It's always been extremely successful. People are always really happy about it. And you can go on our website, you can go on LinkedIn and see the opinions of people, see what people think, and whether that's right for you. You can always contact us as well if you've got any questions, if you've got anything you want to know. And we've got one more special announcement, which is that we are cooking. Composite design is coming to Racetrack Dynamics. We've heard some suggestions from a few different people that have been wanting to learn about composite design. So we are partnering with some more F1 engineers to bring to you the complete guide to composite design in Formula One. You can go online on the link below, racetrackdynamics.com/composites, where you can give us your thoughts, give us what you want to see, what you don't want to see, and how we can and give you the chance to shape the future of this course. It's still in development. We're still working on it. So we want to give you the chance to make the most out of it. And finally, for the certificate of attendance, you can scan that code, or you can go on racetrackdynamics.com/certificate, where you can fill in a form, and we will send you a certificate of attendance within 24 hours. can take 24 hours to send. Please do not email us in 10 minutes when you don't receive it yet. It does happen every time. Give us up to 24 hours and you will receive it. If you don't, please check your spam folder, and then you can send us an email or an Instagram direct DM or whatever you want. Thank you very much for listening, and this is the end of it. We are now open for a few questions in the chat. Thank you very much.
So, Alex, we got some questions in the chat. Do you want me to pass
Someone asked who's the British man's name. I think that means me, Alex Berg. You can find me on LinkedIn and everything else. I'm actually not British, but I'm very good at pretending. What did you say, Javi? Sorry, were there any questions?
Yes. Shall I pass some questions to you?
Yeah, go on.
Are these requirements only for college students, or high school students can apply as well?
High school students can apply as well. This is something that you will see in the website. We also allow students applications from high school students as long as you are a student at some sort of institution and you've completed some sort of high school maths and physics. If you're not sure if you apply or not, please just do apply, and we will let you know if there's any issues, or if we need to know a little bit more about your background to know if you'll be suitable for it, we will let you know.
Yeah, I got some complaints about you, Pedro. People are really liking it. They're really complimenting your presentation. They really enjoyed it. There is a question that I want to pose to you, Pedro. Do you recommend doing the course when I'm finishing my engineer degree or when I'm starting it? Where will you do it?
So a bit on that goes a bit into the career advice, I would say. The more knowledge you can have earlier, the better. The course is structured that everyone that's in an engineering background or course should be able to follow. If, let's say, you start your engineering in September and you have our course in October, you only had 1 month of uni, so you might lack some concepts that we will say, although you'll be able to follow. So my answer is, if you don't think, or if you have already some experience and you don't think you'll be, let's say, understanding zero, I would do it as early as you can. Because if you have the knowledge early, then you can use it in some projects like Formula Student or some racing car motorsport project, and that is useful for you as well. In these cases, the more knowledge you can have, I would say the better.
Something to add on to that, Pedro, from more of the career side of thing, is that when you do a course with us, right, you spend 12 hours locked in a room with Pedro, with Javi, or with me, and you end up learning a lot of things about, what our process was and how we got there and everything. And you end up learning so much more than just aerodynamics or just vehicle dynamics, that it can really help you in terms of shaping the things that you can do for the future. So with all of our courses, you get a free one-to-one session with either Javi, myself, or Pedro, and there you can ask a lot of questions. And we get it all the time of people that are not really sure how to proceed. They're not really sure what to do throughout the university degree. If you chat to us sooner, then we can actually advise you on the project that you should be doing, the experience that you should be getting while you're still in university, and all the things you should be doing before you actually enter the job market. That way you've got 2, 3, 4 years to prepare yourself for that job market, instead of, you get to know us at the end.
Alex, we're running a little bit short of time. Should I pass you some of the last questions that?
Yeah, go ahead, yeah.
People are saying it's not clear how much the aerodynamics course cost. Not seeing the right information on the website. There's only 30 minutes on the website. You want to clarify that briefly, very briefly?
Yes, so standard prices, they're €649 with a 10-minute one-to-one session. They're €699 with a 30-minute one-to-one session. And you can apply for the scholarship where you can get these for free. All information on the website.
Someone is asking, is the scholarship made of online courses?
The scholarship, actually, Pedro, can you go back to the first slide of the scholarship?
And yes.
This one?
further backward. Yes. So it is. It's not just online courses. It also contains. So it is the online course of the Complete Guide to Aerodynamics in F1. It's also the access to our workshop on building an F1 CV. That this one is also online, but it's also it's more of a workshop than a course really. The F1 Aero Handbook, which is a PDF for you to keep forever, and well, effectively all this communication you get with us is not really a course. Is more of a chatting to an F1 engineer one-on-one.
And yes, I have another question, Pedro. Which course did you take at university?
I took aerospace engineering in Lisbon, and my master's was in aerodynamics.
I got one question. What is Rev 1? And thank you. Rev 1 is a revision of the regulations of the limit of the power deployment that is specified only to certain tracks that are a little bit slower, like Monaco. So it's a fancy way of saying in Monaco you cannot deploy full power, essentially. I got, what's the deadline to apply for a scholarship?
Yes, there is very good question. We actually forgot to put that on the PowerPoint. It will be on the website. It is sometime towards the end of this month. So you've got about I think 2 or 3 weeks. I would need to check the exact date, but it will be on the website. So please just check later. It's towards the end of this month.
Another question: are we doing this aero course again at another date? May 17th is my finals week. That's unfortunate. You should ask your professors to move your finals. This is definitely more informative. No, jokes aside, we'll be definitely doing this again, Alex. Won't we?
We don't know exactly when. We can't guarantee any particular dates, and we don't know if it will be 1 week after or 3 months later. But we will definitely do it again in the future.
Right. Someone's asking, will there be a course about electrical part or PU or car in general? We have considered running an electrical, a guide to electronics in Formula One. This is still something that needs a little bit more of cooking, but something that we'll consider completely. So just stay tuned, follow our networks, our social media, join our newsletter, and hopefully you will be informed when this happens.
Yep, we happen to have a lot of friends that can teach a lot of things in Formula One.
So,
anything else, or should we call it a day, Javi?
I think, a lot of positive response. People really enjoyed it. Thanks again, Pedro, for this amazing delivery. Thank you again.
Remember that, Pedro, if you can go to a couple of slides forwards. Remember that for all of you that are here, you can, exactly this one, you've got 40% discount as a launch bonus for the first 5 registrations. The code will become available in just a few minutes when we finish this, code webinar 40. And if you apply for the scholarship with our code Webi Priority, you will also get it will get assessed first, so you have a higher chance of getting it. All applications via our website. There's a big button saying scholarships to which you can apply, or on racetrackdynamics.com/scholarships. This video will be left on YouTube, so you can rewatch it and get the codes again if you want. Remember to ask for your certificate. It can take up to 24 hours to be processed. I think that is everything we have to say, Javi. So thank you very much, everyone.
Everybody, for your trust, for joining us once again, and trusting us to show you a little bit this fascinating world, the engineering insights of Formula One. And thank you for being with us today again. Thank you very much, everybody.
Thank you very much.
Thank
Have
you.
a good day. Bye-bye.